Maybe you know FOIL, and maybe you've forgotten it. Maybe you've learned some of these other factoring patterns, or maybe you've forgotten them. Whether you've seen them before or not, you've probably seen them and just don't remember. Let's go through them. First of all, this page that I'm looking at that comes from a cheat sheet for a college entrance test is kind of misformatted. It's got some things rolled over into lines where they don't belong. So here's the first one that this sheet shows, just this part. And I'm going to have to keep going back to this, so let me think how I can do that. But for now, let's look at this one first. This is foiling. X plus a times x plus b equals x squared plus b plus ax plus ab. Now you're used to doing foiling like this. Let's say you have x plus 2 times x plus 3. And you can foil any kind of binomials. Binomial means it's got two terms. Even if there's not a variable in there, it doesn't matter if it's x or one is a, one is b, one is z, one is q. You foil it the same way. And really, FOIL is just a way to remember to multiply every term by every other term. So it's first times first. X times x is x squared. And then outside times outside. X plus 3 is plus 3x. Inside times inside. 2 times x is plus 2x. And then last times last. 2 times 3 is 6. Now, most people would automatically add like terms. That's what you do when you're dealing with variables, is you add like terms. This would be x squared plus 5x plus 6. And that's correct. However, sometimes for factoring, especially when you start with this, or rather, I'm sorry, when you start with this, you may want to remember what this FOIL pattern looks like, because this could help you break things up. So we could rewrite this as, I'm going to rewrite this one in the style of this. We could rewrite this as x squared plus 3 plus 2 times x. All I did was take these two terms and I factored out an x. If I factor out an x, I get 3 plus 2 times x plus 2 times 3. So notice, here's x, a is 2. I've got x plus a is equal to 2, times x plus b is equal to 3. And now I've written this in the style of this. It's just another way to combine things or group things. So I've, excuse me, x squared plus b plus ax, b is 3, and a is 2. So plus 3 plus 2 times x plus a times b plus 2 times 3. Most of the time with this, you wouldn't need to write it like that. You just write it, well, wait a minute. You'd write it like this. Forget that. Well, let me get rid of that arrow to make it clear. You would write it like this. But you can always break it up to be like this so that you can see the b and the a. And here's the a and the b. So you could see those numbers separately. So that's foiling in this style, where you group it so that you originally started with x plus a times x plus b. You can still see that the a and b in this when you have it grouped like this. But again, most times when you do FOIL, you're going to write it this way, and you're not going to worry about grouping it so the b's and a's are separate. Think about going backwards from this. Let me erase this stuff. And think about going backwards. I'm going to keep this part. In other words, this is a tool that could help you factor when you have a polynomial. I want to keep FOIL, and I want to keep that. So it could help you factor a polynomial. I'll show you another way to factor polynomials that might be easier to remember. But let's say you have a polynomial that looks like that. Second degree polynomial. Let's call it quadratic. And usually we say equals y or equals f of x or equals 0. And you need to factor it because you need to find out what values of x make that equal to 0. That's a common thing that you do with quadratics especially, but polynomials in general, is you factor them to find the x-intercepts, to find out where this graph, if it's a quadratic, it looks like a U, where that graph crosses the x-axis. So how would we factor that? Well, you look at 5 and you look at 6. You need numbers that multiply to 6 and add to 5. So let's think of some factors of 6, 2 and 3. And 2 plus 3 is 5. So we've already found our terms. So now we can rewrite this as x squared. Usually you would skip this step, but 3 plus 2 times x plus 2 times 3. Like I said, normally when you're factoring, you skip this step, but this is really what it looks like. You found whatever the last number is, the constant. What numbers multiply to the constant and add up to the number in front of just the x. So in this case, 2 times 3 is 6, and 2 plus 3 is 5. Now, again, you'd usually skip this step, and you'd look at this and say, okay, I found factors that multiply to 6 and add to 5. So you'd put an x like that, and an x like that, and plus 2 plus 3 equals 0. And then the next step you would take is, after factoring it, the reason you did that is so you could solve for x. X plus 2 equals 0. Subtract 2 from both sides, x equals minus 2. So notice what happened. The sign just switched. And then x plus 3 equals 0. X equals minus 3. So that's what this first fact on this, it's the TSIA2. It's a Texas College Math Entrance Exam. People take this test to see where they place for college classes so they can skip certain classes. That can save you a lot of money. So this first fact shows you, it shows you from going from the binomials. Whoops, I minimize my page instead of circling it. You go from the binomials to the quadratic or polynomial in a form that exposes what the A and B are, shows you exactly what the A and B are. But normally that's not the way you go. Normally you're going to go for this one from the polynomial, like in this case x squared plus 5x plus 6, to the binomials, so that then you can solve for x, see what x equals. Let's do another example of that. And again, normally you're going to skip this step. I can think of one place where you don't skip this step, and that's on SAT and ACT tests. Sometimes you need to see those numbers, and they give you questions, specific questions, that make it necessary to see those numbers. All right, let me delete this stuff again, and I'm going to give you another. It's going to take me a second to figure it out. Let's see. It's going to be x squared. I don't know what the term in front of the x is going to be on here yet, so I'll leave it blank. And let's see, 12, 4 minus 3. Okay, plus x, and I'll say, I don't want that to be a plus. I want that to be a minus 12. We're going to do one minus 12. All right, so again, remember, I'll put it in this format just so you can see it, but really we're going to skip it when we try to solve for x. But that's where the use of this comes in. We want a number. This is called reverse FOIL. Factors, rather, that multiply to negative 12 and add up to positive 1. When we just see plus x, it means plus 1x. So what do we have for 12? 2 times 6 is 12, and one of them would have to be negative. We want that to be positive, so I think the smaller one has to be negative. Well, 6 minus 2 isn't positive 1, so those factors don't work. And even if we reverse the minus sign, negative 6 times 2, these are just factors. I'm not saying 2 minus 6. I'm saying 2 and minus 6 are the factors. 2 times negative 6 is negative 12. Negative 6 plus 2 is negative 4. So those ones didn't work either. Any other factors of 12? Well, 3 and 4. And when I add them, I want it to equal to plus 1. So I'll make the 3 negative. Looks like I crossed it out. So 4 times minus 3 is negative 12. And 4 plus minus 3, or 4 minus 3, is positive 1. So those work. So now, again, normally you wouldn't do this, but I'm just showing you on this one. I could rewrite this as x squared. I could rewrite this as x squared plus, now if I keep it in this format where the second one is first, negative 3 plus 4x, and then plus negative, I want to put that one first, 4 times negative 3. So now you see I've got the a and b exposed here, so that I know this would be written as x plus 4 times x minus 3, or plus minus 3. X plus a negative 3 is x minus 3. So, and let me fix that 4. Sometimes I lose control of my writing. Get rid of that and put it like this. So again, usually I'd skip this step and I just write it like this, because I found that negative 3 and 4 multiply to negative 12 and add up to be positive 1. So now I factored it. And really this should be equal 0, because normally we're trying to solve for x, trying to find where x equals 0, so we know where this thing crosses the x-axis. And at this point, again, this is called the zero product rule. If x plus 4 times x minus 3 equals 0, then one of them must be 0. 0 times some value, let's say this isn't 0, I'll just put not 0. Some number that's 0 times a number not 0, 0 times anything is 0. And if this one's not 0 and this one is 0, not 0 times 0 equals 0. So it's called the zero product rule. And really, all you do is switch the sign. So x equals minus 4 and x equals positive 3. Those are the values of x, where this thing, negative 4, let's say that's over here, and positive 3 is over here. Those are the values where this function has an x equals 0. In other words, where it crosses the x-axis. So that's the purpose of this fact that they just gave us. This FOIL x plus a times x plus b equals x squared plus b plus ax plus a times b. Again, we don't normally write it in that format, but we can. But really, it's reverse FOIL. And it gives us, we have to find a term that multiplies to the constant, just the number, and then it adds up into whatever number is in front of x. So that's it. Now there's another method in case there's a number in front of the x squared, and this should not be negative x squared. I just put that line there to point to it. I should have made it an arrow. But anyway, if there's a number in front of x squared, then it's done a different way. But that's not the subject of this video. Well, let's make it the subject of this. No, we won't. It's too much. It's not the subject of this video. So I will now go on to the other things that were on that cheat sheet. The next one we have is the difference of squares. And this is not wrapped the right way, so really that one goes together, and this one goes together. I guess that's good enough. So this is the difference of squares. Crop it, and then I want to make this bigger. And I'll move this one over here, just so it's where it belongs. Difference of squares. So this is how to factor something. You may have something that looks like, it could be numbers, it could be variables. A lot of times it's something like this. X squared minus 9. And you're looking for perfect squares because you know this pattern exists. Well, you can rewrite 9. It's a perfect square. it's a perfect square, is 3 squared. X squared minus 3 squared. So A is X in this pattern, and B is 3. So we have A squared minus B squared equals. So A is equal to X, and it says A plus B, X plus 3 times X minus 3. So there you have it. You can factor something by difference of squares. X squared minus 9 is the same thing as X squared minus 3 squared. And then because we know we have this difference of two squares pattern, or difference of squares, it's X plus 3 times X minus 3. Probably wouldn't make sense to do it with numbers because you could always square the numbers and then subtract them. But with variables, let's say you had Q squared minus G squared. Well, same pattern. That would be Q plus G times Q minus G. Difference of two squares. Usually it's one variable and a number. What if we had T squared minus 16? You can rewrite that as T squared minus 4 squared because 16 is a perfect square. And then according to this pattern, that equals T plus 4 times T minus 4. Difference of two squares. I'll do one more. What if we had, let's have 25 minus x squared? Well, 25 is a perfect square. That's 5 squared minus x squared. And that can be rewritten as 5 plus x times 5 minus x. Difference of two squares. It's just a pattern. It's called a factoring pattern. If you know it, sometimes it will make it easier to factor. Well, it always will make it easier to factor things because you can check this and see if it is, in fact, the difference of two squares. If it's not, use something else. You can use reverse FOIL, for example. All right, difference of two squares. The next one is a formula for a plus b squared and a minus b squared. We'll do them both together. So we get rid of this one. Remember, this one is the FOIL that I'm now deleting. This one is the difference of squares. For some reason, the word wrap went bad. And now we're on this one. We did this last one, this reverse FOIL, which is all of this stuff. We did this along with the FOIL. That's just a pattern that goes both ways. And now we have this one. And let me crop it, and then we can expand this just like we did before. Now there's another way to write each one of these. Notice this one says a plus b times a plus b. That's the same as writing a plus b squared, because it's a plus b times itself. That'd be like saying 2 squared equals 2 times itself. So this is just, the first one is a plus b squared, and the second one is a minus b squared. It's a minus b times itself. These are ways that you can recognize. And this one, there are problems that go both ways, either from a plus b squared, and then you have to write the quadratic, or a minus b squared, and then you have to write the quadratic. But it could also be you have a quadratic and you can recognize it with this pattern, and then you can do that. So let's try this. Let's try this out. What if we had x squared plus 24x. Wait, that's not what I want. 24x plus 6x plus 9. Well, you might recognize that as 6 is 2 times 3, and 9 is 3 squared. So we have, and let's say x is a and 3 is b. So notice we have a squared, because a is equal to x, plus 2 times a times b, because a is equal to x and b is equal to 3, plus b squared. So you might notice that. You might be able to pull it apart. And at that point, you would know that this equals x plus 3 times x plus 3. You have it there. You go the other way, too. What if we had, you needed to find out what x plus 9 squared is? Well, look at our pattern. That's x plus 9 times x plus 9. And x is a and 9 is b. Just so we can plug it into our pattern. So this is a squared, which will be x squared, plus 2 times x times 9 plus 9 squared. So we're just using these a's and b's to relate it back up to the pattern there. Well, that's x squared plus 18x plus 81. Just the pattern. And you can, once you work with them a little bit, you will recognize them when you're dealing with a plus b squared. It's very simple because then you just get to the quadratic, which is a polynomial. But when you're going from the quadratic to get to a plus b squared, maybe it takes more practice to recognize it. But anyway, that's that pattern. So let's do another one with the plus, and then we'll look at one with the minus. What if you had, hold on, I'm getting the wrong tools here. What if you had x plus 7 squared? Well, just so we can recognize the pattern, it's going to be x squared plus 2 times x times 7 plus 7 squared. And that equals x squared plus 14x plus 49. So just follow the pattern. And then likewise, if it were x minus 7 squared, it would be x squared minus 2. And that's the only difference here when it's minus. Just that sign in front of the second term, whatever's in front of the, well, x for ones that look like this, where it's x plus or minus something. The only one that gets the minus sign is that middle term. So minus 2 times x times 7 plus 7 squared. And that equals x squared minus 14x plus 49. So that's the only difference. If this was x plus 7 squared, that 14x would be positive. If it's x minus 7 squared, the whole thing is squared, then that middle term is negative. That's the only difference. Now, the x doesn't have to be the first term. I'm going to do another one. What if it were 7 plus x, the whole thing squared? Well, that's going to be 7 squared, which is a squared. A is 7, plus 2 times 7 times x plus x squared, b squared, because x is equal to b, which is 49 plus 14x plus x squared. Now, normally you'd write that in a descending power of x's. But that's how you do it. And that looks exactly like x plus 7 squared because all the signs are positive. Remember, x plus 7 squared is equal to x squared plus 2. See, always one number goes haywire. Plus 2 times x times 7 plus 7 squared, and that's x squared plus 14x x plus 49. Looks the same. Now again, this one, we switch the order of them because normally you write polynomials. It is standard to write polynomials in descending order of the exponents. So we get x squared, x to the first. If there is no exponent, that just means x to the first. And then x is to the 0 power, because anything to the 0 power is just equal to 1. So we don't even write it because it's just equal to 1. So that would be if it was 7 plus x, the whole thing squared. Let's do another one to show you what happens when it's minus. 7 minus x, the whole thing squared. And this is where it's going to come out to be different than x minus 7, the whole thing squared. So remember, we use the same pattern. It's going to be 7 squared minus 2 times 7 times x plus x squared. Well, I think it's going to come out to be the same. I guess I misspoke. So this is going to be 49 minus 14x. Yeah, it's going to come out the same. Plus x squared. And again, we normally write that. We flip it, and that would be x squared minus 14x. Only so that we can get it in order of the powers, plus 49. Okay? And then this one, watch what happens. It's going to be x squared minus 2 times x times 7 plus 7 squared, which is x squared minus 14x plus 49. It's okay, it comes out the same. But anyway, that's the pattern. A plus b squared, which is a plus b times a plus b, is equal to a squared plus 2ab plus b squared. A minus b squared, which is a minus b times a minus b, equals a squared minus 2ab plus b squared. That's the pattern for a plus b, the whole thing squared, or a minus b, the whole thing squared. Those are factoring patterns or FOIL patterns, things that it's just quick. Once you work with it a little bit, and you may already have it, you've kind of got it memorized, and you don't have to even worry about foiling because you know, okay, a plus b times a plus b is a squared plus 2ab plus b squared. A minus b times a minus b is a squared minus 2ab plus b squared. Let's just do one of these. Let's FOIL it just to prove that they're going to be the same. I just want to show you that foiling still works on these. It's just that these are shortcuts. These patterns are shortcuts. So what if we had a plus b times a plus b? We're going to FOIL it and show you it comes out to the same thing. That's why you just memorize it because it's a quick pattern. All right, first times first. That's a squared. Outside times outside. Plus b squared. Inside times inside. Plus ab. Last times last. Oh, wait a minute. Start again because I did the wrong one for outside times outside. Sorry about that. A times a is a squared. Outside times outside, a times b is plus ab. Ha-ha. Why didn't you catch that mistake? I was testing you. Inside times inside is ab. You might write ba, but it's the same. And then last times last, b squared. So you get a squared. Add like terms, there's two ab's plus b squared. So see, if you FOIL it, it comes out the same. But since you know it's a pattern, you could be very quick with it. It wouldn't take as much time as actually FOILing it because you've got these patterns committed to memory and you recognize them when they happen.